my all-girls robotics club.
Yay!
Yay.
Where's the microphone? Who's got the microphone?
I don't need a microphone, do I? So the girls, they call themselves the Ice Cream Robotics Club.
Ice cream?
Ice cream, like something you eat.
I like that. Ice cream
And
robotics.
this is their project. So we've been learning, we learn all year round. We try different types of products and projects. Currently the girls are working with the We Do 2 made by Lego. They also had an opportunity earlier this year to beta test the new Lego Spike Prime kit. And I think they had a pretty good time with that, huh? We have a picture of one of the models here on their poster board. So they've been learning different projects with the We Do 2. And learning about the moon and rovers, because we're not only just learning about robotics and how these different machines and mechanisms work, but also real world applications. How are they really used? So I've been talking with the girls quite a bit about the moon rovers first, because those have been around for a little while longer. And then next we'll be working with Mars rovers and talking a little bit about that. So the girls want to go ahead and do the rest of the presentation. They can tell you all about what they have here, what they've made, and what they've learned. And I'm just going to stand here and support them. And this is Kiona and Shivani.
You might want to get the mic for them
Yeah.
because they're
For
not
them,
going
yes.
to be able
Microphone.
to. I think it's on the podium, I heard.
Check your pocket, Fred.
Test 1, 2.
Make sure you tell them a little bit about that.
Test 1, 2. Here you go. Tell them about your robots.
Can you move the sign a little bit?
Yeah.
Because I can't see anybody.
So stand up here.
There you go.
Oh, yeah, there you go. There you go.
Stand up there.
Just tell us about it.
So, I'm Kiona. I play acoustic guitar, and I want to become a mechanical engineer when I grow up.
Yeah.
I'm Shivani. I like singing and drawing, and I want to be a mechanical engineer too. So, the moon fact is the moon is the Earth's only satellite. The second fact is our moon is not the biggest planet. It's the 5th biggest satellite in our solar system. The distance to the moon is 384,403 kilometers, or 857 miles. The next one is the moon orbits the Earth 27.3 days. The last fact is the moon's gravity is 17% of the Earth's gravity. There's more facts, but we didn't read them all.
Very nice.
Yeah.
That there have been a lot of rovers that have gone into the moon, and we've made one of them.
Is this the demo? The big demo.
I might have turned it off. Put it on top of the computer.
Watch your step.
Be careful. Oh, and also hit the volume.
Hang on, I gotta turn the volume on.
It's showing something on the screen, you might not be able to see it. Tell people what you built and tell us a little bit about building with this and how you built this.
Just say it.
Just say what you know.
Tell us what it did.
Yeah, what it is.
Brag about yourself.
Here, I'll set it up and make it.
I saw the robot push something.
I'll do it again, you describe what it's doing. Push the button, describe what it's doing.
So it's basically taking the rocks, like the moon rocks.
Yay.
So the moon base it has astronauts studying about all the different moon rocks, and then there's a whole group discussing something.
And then what's this? Shivani, you worked on this. Tell me about this.
It's basically a rover I made.
What's this?
Those are the craters and mountains on the moon. These gray parts and white parts are ice.
And tell them they can see
After, we're gonna put it back there so you can always see it.
Thank you, Eva. Eva really helped us out at the Maker Fair this year with the Robo Jam. Her and Eloise really ran the show there. Can I help you here? Okay. Watch it.
We'd love to do it again.
Okay, my name is Namadi, or Didi for short. So I brought this robot before. I brought it before as a double comedy show. In fact, wasn't it last weekend? We also did the double humanoid comedy show, me and my daughter. She brought her robot, I brought mine. And so I figured, since this is October 30th, I would make a couple updates in honor of the holiday. So this robot has multiple modes. I put it to depressing robot poetry mode. I changed the lights from perky blue to slightly scary red. Slightly scary. So let's hear how depressing
I work
this
and love. Don't have
poetry
joy
is.
beside that. I make myself happy. Don't know how to express her.
Can you please make me feel that I can cry and share my problems?
Very sad.
Can you give me time to feel the love? Want to do the thing you are doing for long?
Yeah, and I changed the artwork here too. So, yeah, it's very sad, but that's what our future is going to look like, so don't worry.
Stevie Davis, ladies and gentlemen, and the end move.
Yes.
This robot's
Beside
name.
that wall.
Yes, this robot was designed by a guy in France. His name is Gail Langevin. And so he put the robot open source on a website so anyone could download it. And I made a couple modifications by putting a screen in it and two large speakers that can go up way higher, but I'm polite, so I'm not going to do that.
of sorrow. The world withdrew Logan.
Run what you brung. Run what you brung. All right, Kyle, why don't you come up and tell us about your robot? Kyle, ladies and gentlemen.
Hi everybody, my name is Kyle. I'm a computer vision engineer. So essentially what I have here is sort of an autonomous platform that I've built myself. There's a Jetson Nano on here that's communicating with an Arduino Atmega 328 for motor control. And I basically have ROS running on here right now. The control is a little rudimentary. I'm just using WASD right now. I have one node reading my key input, another one communicating with the Arduino through serial. Basically, my motivation for building this was sort of to have my own platform to implement and test my own perception algorithms, including but not limited to mainly SLAM. I'm trying to do a couple different things here. You may have noticed there's a LiDAR on top of there. That's an RP LiDAR with about 12-meter range. It's a 2D laser scanner. There's also a SparkFun IMU and an Intel depth camera with another integrated IMU. So basically, I've spent the last couple of weeks building out this system on top of this mobile robot platform. I had to get another L298 for motor control. I was going to use the integrated one, but I think it wound up being defective. But basically, my goal here is to have my own platform to implement and test my own autonomy algorithms. I've already more or less somewhat started with that. I'm in the process of implementing the iterative closest point, or ICP algorithm. In summary, that's just a way to take one laser scan, take another laser scan, and incrementally align them to find the transform between one pose and the next to help you with your odometry. So that's sort of what I'm working on now. I kind of have a roadmap for maybe the next month or two where I'd like to work on ICP, then transition maybe towards more grid mapping and integrating the IMU with that. And then after, and again, I want to use ROS as a framework here, but my goal is to implement these algorithms from the ground up. And I've already more or less done some of that in part because I've also worked on my own extended Kalman filter implementation in C++. By the way, this is all on my GitHub. I also have a YouTube channel. It's relatively new, but okay. It's relatively new, but it's something I'm starting out to sort of document this process. It's real easy to remember. It's Kyle Builds Robots, just all one word. So I've already uploaded maybe a couple of videos here. Yeah, try to get on the camera here. You can see, yeah, that's just a screen I have for debugging. That's hooked into the Jetson Nano here. A couple things I will say is that I already have learned a lot about the power distribution needs of the Jetson Nano. You guys laughing, you already know what I'm talking about. Yeah, I actually wound up having to get my own 5-volt, 5-amp regulator, and I'm running this off of two 7.2-volt batteries. So one of them going into the regulator for the Nano, and the other one is going into the motors. But I imagine I'll probably have to distribute the power even a little more evenly, because you notice I have a USB port on the 7-port USB hub on the side here, and if I'm not careful, that can sap up some of the power too. So still a little bit of a learning experience, but it's one that I'm pretty excited for, and that I'm kind of proud of so far. But yeah, that's more or less a summary of what I've been.
How long have you been building robots?
It's about middle school, maybe 2010.
How many years?
About 8-9 years, something like that. Yeah. I've been in the industry about 1 year. I graduated in 2018. Yeah.
High school or college?
College. But yeah, so that's in essence what I've been working on this last while. Hopefully you guys find it interesting. If you want to sort of follow me on this, like I said, I have a YouTube channel if you guys are interested.
Post it on the mailing list.
How do you spell Kyle?
K-Y-L-E.
All right.
Kyle Builds Robots, all one word.
Post it on the mailing list. You're on the mailing list, right?
I think so.
Okay, go to the HBRC mailing list. You should be getting notifications of the
There's
meeting
been a
and
half
stuff.
dozen mail messages over the last week or so.
Okay. So yeah, did anybody have any questions or?
You know why the motion? Go ahead. You know why the motion is a little jerked in?
Yes, actually, that's sort of the way the Arduino is set up right now. It's set up to take just character key inputs like WASD, move forward for 100 milliseconds, and then stop. Ultimately, what I want to be able to do, oh, you pulled it up. I mean, yeah, like I said, I already have a couple videos up there. The next one I want to do is hopefully when I finish this ICP implementation, I'll probably do a quick video on that. But I have one that's sort of an introduction and more or less demoing the same thing I'm doing here, and I also have one sort of demonstrating my remote data capture system that I've been working with a little bit to sort of get my own data sets while it's on the robot and then work with it separately. So yeah. Thanks, everybody.
Kyle makes robots.
Kyle builds robots.
Kyle
That is
builds
also true.
Kyle builds robots.
That's also true.
Very good, very good, very good. Okay, who's next?